Okay, so up and running again. This is going to be a lot of repetition here, a lot of reps on solving equations, and I'm going to do verification from a graphical approximation standpoint. I think it's good practice for you to visualize these equations. So we'll have a little practice there. These are the equations that I'm hoping to have you work with. Let's push this down a little bit so all of them can be seen. I think if you take a moment to look at the column on the left versus the column on the right, you'll see some noticeable differences. And I want to stress those. In fact, I want to stress them right now. So you pause the video if you want. Look at the two columns. What's the difference? Well, these are all x to the 1 problems. Isolated here, right? At x to the 3, but you don't see x squared and x to the first are unlike terms. So these readily are solved most quickly and easily with inverse operations, whereas these variety of skills are necessary to solve them. Sometimes we can rewrite them and use inverse operations. Sometimes completing the square, quadratic formula, factoring, of course, is a basic skill. And then we have a couple of other equations over here that I'll just show you how to work with and do. Okay, so in this video, look at the ones that you feel like you need a lot of practice with, and ask me for rapid fire 5 in the next week, and I can do 5 problems of the same type. Right now, I'm just going to talk about solving that left-hand column using inverse operations, but as a skill, I think it's important for you to be able to see these as 2 graphs. All right, so this one here is 5, 6. So this is the location 5, 6. And then if we go up by 7, 12, and down 3, then over here we have 12, comma 3. Just got to be able to show me that you can do that on this test coming up. All right, so we want a height of 10. Here's 3, here's 6. I think 10 is probably over here at an x value like that, which translates to, if that's 1 unit, right, then I approximated 5, 6. I don't know, we're near -6, something like that. Ballpark guess. So now let's just solve it quickly and find out how close we were. All right, so subtract 6. Boom, it's gone. Multiply by 7. 28, gone. Divide by -3, minus 28 divided by 3. And my guess is not the greatest. So that is, minus, what's the first one? Minus 27 divided by 3, right? Is 9 minus 9. So we're a little bit more towards this side, but hey, it's okay. I'm going to accept that. I'm in the right ballpark. Okay, so it was just a quick approximation. All right, so that's that answer. Minus, did I ever answer it completely? Yes, I did right here. Minus 28/3. Okay, so now we're going to move right along with my trusty science card. There we go. So -5, 7 is the vertex of this quadratic. -5, 7. Doubling the squaring process, it's going up pretty quickly. So if we put a 0 in there, 57 is the y-intercept. And 57's up here somewhere, right? And I want -10. Oh, -10's down here. So I said that's 7 units. Somewhere down here is -10. And so, when am I going to hit that? Well, oh boy. I think we're going to hit it with a very, small negative number. That's the best way to describe that number. And then a counterpart, the same distance to the right, to the left of -5. So I get some ideas of, I'm looking for a number near -1, -2, probably closer to -3 even, but let's go find it. So we subtract 7, that's minus 17. We divide by 2, and these are imaginary answers, by the way, right? Divide by 2, minus 17 over 2. And now I'm going to hit that with a plus minus 17/2. Imaginary. And now we're going to do measuring from -5 plus or minus the square root of 17/2 I. Now 17 halves is pretty close to the number 9. Right, 18 divided by 2. Okay, and 9 is roughly 3 units, so square root of 9 roughly 3. So -5 plus or minus 3 puts me at -2. You know, I was roughly guessing one of my answers would have been that. Of course, it's imaginary, right? So those are your answers to this problem. And that's that. Okay. So let's look at the next problem. I've already done some of the graphing to speed up the video here a little bit. Righty, so I got an exponential function, growth. The base is greater than 1. And so my first jump of 15 is on top of 7. And that happens when x is 2, 2 minus 2 is 0, 3 to the 0 is 1, 1 jump of 15 plus 7. Then I just decided to, you know, use the number 3, right? Because that means I'm going up 45 units and I want a height of 12. Well, a height of 12 is somewhere over here, yes? So I've got an answer that, remember, this is only 1 unit of change here. So, you know, I'm looking near x equals 1. In fact, I can see it from this, that it's going to be 1, but that's some experience. So let's just find it and let's talk about the inverse operations. Making sure you can see everything now. I'm sure you can. So we get rid of 7, there's a 5. We divide by 15, which makes this 1/3. And then we have 3 to the x minus 2. So that x minus 2 is the exponent that you put on top of 3. Be careful how I write that. That is the exponent that you put on top of 3 to get 1/3. There, that was a little awkward there for a moment, but that's correct now. And we've been working with this for the whole semester. We started with that on day 2, maybe even day 1. So that's -1. So x minus 2 equals -1, therefore x equals 2 plus 2 minus 1, 1. And we said, yeah, thought that was going to be in the ballpark. Turns out it was the exact answer. All right, now we got a little square root function, but isolating x won't be hard. We'll just do the inverse operations. Let's see now, let's get this back a little further. Okay, move that chair. See, does that capture everything? It does. All right, so square roots change slowly eventually. They actually change a lot in the first unit of change. I feel like I'm not saying exactly what I want to, but we practiced this and I just put an at random point here. I decided to pick 8 because it's friendly. So 8 minus 4 is 2. Square root of 4 is 2. -4 plus 8, +4. Just frame of reference. And of course, you know, the domain of this is x has to be greater than or equal to 4. Right? Because we have to have positive numbers or 0 inside the radical symbol. So now my estimate for -2. Well, I know it's changing very slowly, so I'm looking for a fairly sizable x value, maybe around 30. You know, that's a rough guess. All right, so let's find it. Let's find it now. And I'm just guessing. Maybe I'll use the approximation symbol. I think I'm out here somewhere. So let's subtract 8 minus 10. Let's divide by -2. +5. What's the inverse of square rooting? Squaring, which leaves us x minus 4. And x is equal to 29. Yeah, good guess on that one. So, well, of course, you can always, you know, put the 29 in. That goes for every single one of these equations. I mean, there's verification right here. 29 minus 4, 25. What's the square root of 25? 5. What's 2 times 5? -2 times 5, -10 plus 8. Okay, -2. All right, if you got time, by all means, get your answers, plug them back into the equation. I'm just trying to get you a little more in-depth conceptual awareness here by doing some graphical approximations. Do I have this one? I didn't graph this one because I wanted to do it from the get-go. All right, so let's look at the inverse of exponentials or logs. Exponentials, we do dotted line, horizontal, and then vertical jumps, right? And the second jump divided by the first jump is what forms the base of an exponential function. All right, this is the inverse. So I'm actually gonna do a vertical line and horizontal jumps. And the first jump I'm gonna make is 5. And then I'm gonna do 3 times 5, 15. And that's gonna give me some framework here. All right, so what's the critical number? All x's in this equation have to be, why don't I write greater than 6 this time instead of equals? Okay, because that's where the graph shows up. Every single x on this curve is bigger than this number. And there's good reason for it, because logarithms are the inverse of amounts that are generated from growth and decay functions. If we don't have an amount of something, which is a positive amount of something, then there is no inverse to that. Got to have something. If we're talking about time to growth or time to decay, there's got to be something there for the y values. And we're really logging the y values that come out of growth and decay functions. Okay. So what makes x minus 6 over 5 greater than 0? X's have to be bigger than 6. So now I'm suggesting that if we add 5 to 6, that 11 is going to give us a nice user-friendly calculation. 11 minus 6 is 5, divided by 5 is 1. And everybody has been practicing that exponent for 2.5 to 3 months. And that is 0. Why? Because 3 to the 0 is 1. Yeah, that might be the last time you get a chance to hear that and think about it. So try to process that. All right, so I just made a 0, which gets me 7. And the easier one now is 15 minus 6. 15 plus 6 is 21, excuse me. That should be a very friendly number. 21 minus 6 is 15. 15 divided by 5 is 3. And I don't think there is anyone who doesn't know the exponent. You put on top of 3 to get a 3. You've created a 1, which we now know is 4 plus a 7, which is 11. I never liked the same number showing up, but it did. All right, so I want a height of 15. 7, 11, 15 should be about here. All right, and that number should be again near 30, I guess. Let's find it. Big guess on my part. Well, let's find out what it is. Subtract 7. We got 8. Divide by 4. We got 2. What's the inverse of log? Base 3? 3 to them. That's the inverse of that, is 3 to that number. What am I doing? 3 squared is 9. I'm going to multiply that by 5, which gets me 45. And then I'm going to add 6. Woo, it did take a long, bigger than 30. Wow, because this is really going slowly out here. So to get, yeah, that makes more sense. So 51. But let's check it out. 51 minus 6, 45. 45 divided by 5 is 9. What's the exponent you put on top of a 3 to get a 9? A 2. 2 times 4 is 8. 8 plus 7, 15. Okay, moving right along. 125x cubed minus 7. We haven't had much experience graphing cubics. That'll come in the next class, next algebra class. But we have looked at the geometry of change a little bit. And this is changing. Cubics are changing when there's no box. It's not changing much. Okay, so it actually has a point of inflection here. And that's what that graph is going to look like. And it's going up with a number like that pretty quickly. Yeah. So what do we have? We've got 1007. Whoa, way up here. But I don't think it's going to take an X all that big. You know, I mean, throw a 1 in here. 1 in here gets you 125 minus 7, right? Which is a pretty significant jump, vertical jump. So it's moving up very quickly. So it's going to be a small x, you know, around 2 or 3. We can estimate 3 cubes 27 times 125. My God, we're already past that. So it's probably 2 because these are canned problems. All right, so what are we going to do? Did I write minus 7? No, it's plus. Over there, yeah, it was minus 7. Well, I think I want to do +7. I'm gonna change that on the fly, because I'm really not trying to give anyone, any. Well, it was -7 to start. Let's keep it that way. All right, -7, gotta add 7. 100,1014. Not the friendliest. Gotta divide by 125. And then you gotta take the cube root. I'm sure I probably meant a plus, so that we take the cube root of 1,000, which is 10, right? Where was I? Oh, I'm just copying this. Brain got a little sluggish. No, notice there's not a plus minus there, because negative roots exist. Right, there's no symmetry here. So, we've only got one intersection. Okay, so when we're solving equations, we don't put plus minus in front of odd roots. All right, enough said on that. I got to get this thing done before class starts. And you're jumping around, looking at problems that well, I think it's probably good practice anyway with the graphical. So I can see 5, 6 as a vertex. I can see +7, so it's pretty steeply V-shaped going up. I threw a 0 in just for the heck of it to get 41, and 14 is above 6. So, I've got numbers that aren't too far from 5. 5 units of change got me 35 units. And so probably looking at 4 and 6 as the answer, something like that, but 3 and 7, something like that. All right, so how do we do this? The left side is the negative, so I'm decreasing. I know there's arrows here, but you follow the finger, decreasing, then increasing. So I'm gonna write -7, x -5 + 6 = 14. And the other piece is +7, x -5 + 6 = 14. I'll just solve those quickly. Subtract 6, 8, divide. Did I not get a canned problem here? Didn't really want, I really wanted some integers here, but anyway, it's what I got. So I got to divide by -7, -8 sevenths. Well, on the test, it'll be easier. And then I got to add 5. So -8 sevenths + 35 sevenths, that's adding 5. Gets me an answer of -20, brain's slowing down here, -27 sevenths, which is, not the answer I was anticipating. Oh, that's on the left side. So that's okay. This is the one that'll be closer to. So 8 sevenths + 35 sevenths is 43 sevenths, which is more than 5 units, but not a whole lot. So 42 sevenths. 42 sevenths is 6, and I think we said we'd be around 6 units. So 43 sevenths is acceptable. You'll get integers to work with. You got a lot of problems to do on this test, and I don't want you getting hung up on straight math. But that's what that would have been. All right, so this is now still inverse operations. I think I just erased the graph. I'll have to get it back again quickly. That's a linear function because it's to the first power. So -5, we'll call that -5, down 3/4. I've got a line that's decreasing. This one is +1. So if that's 5, down 5, that's about 1, up 2/5. So I've got an intersection over here at some x value that looks like it's around -5. Real ballpark guess on my part. Let's solve it. How do we solve this equation? Making sure you can see everything. We get rid of the factors here, 4 and 5, by multiplying them out of the problem. 4 cancels, I get -15x. Nothing cancels. 20 times -5 is -100. The 5s cancel. I get 8x. And nothing cancels. 4 times 5 is 20 times 1 is +20. I don't like dividing by a negative, so I'll add 15 to this side. Subtract 20 from this side. And it looks like my answer is -120/23, which is near -5. Yeah, good. So not a bad guess. All right, so all of those were done with inverse operations, really. Now we turn our attention to one that we can't do with inverse operations. But we can see x squared, linear function, so that's intercept of 12, and it's going up at 1 to 1. So I can see that I've got 2 x's. one over here and one over here. They're gonna be intersecting there and there. And so one negative, one positive. Looks like this one is a little further to the left than that one is to the right, but I'm not sure. Let's just find it. So we always set these babies to 0. Hope we can factor in. Looks like we can. X minus 4 times X plus 3. So I was wrong. This one is further. And I guess yeah, I guess. Yeah, you can see it is a little further. And so a lot of you are forgetting to write equals 0. I wish you would remember to do that and then answer the question. Okay, if that's all you do on the test, you're not going to get any credit. Maybe half a point. I don't know. We'll talk to the other folks. Okay, so there's your answer for -3. So, if you can't do things with inverse operations, it's nice if you can write something as a product, set it to 0 because you can see your answers. Just another something you want in your bag of tricks. Okay, so here's another similar question. All right, minus 4x squared, it takes a minimum. 0 squared is where you get a minimum, so it's got well, in this case, a maximum because it's negative. So I got a cup shape down, goes through the origin. So does 8x, right? Over 1 up 8, put in a 0, so you can see 0 works. But there's also another intersection over here on the left side, a small negative number. Okay, so what do we have here? We've got 0. I don't like dividing by negatives, never have. So I'll just make minus 4x squared appear on the other side as positive. You could take out the common factor 4x. I don't. I always just take an x out. And then it's 4x plus 8. I find I don't have to think quite so much. And so now I can see my answers 0, which we said you could see. And it looks like it's -2. Okay, I believe right there in intersection of -2. Okay, nothing there to worry about. And factoring when you have coefficients other than 1 has been challenging for some folks. I'm sure this one probably can be factored. Or I probably wouldn't have given it to you, but you can always check factoring by what's called the discriminant b squared minus 4ac, which in this case is 100. That's this squared. 4 times 3 is 12 times 8 is 96. And that's inside a square root. And the square root of 4 is a very nice user-friendly square root. And so if you have a perfect square inside that square root, it's factorable. So let's go ahead and factor it. Factors of 8 are 1, 2, 4, and 8. And all of these are going to be 3 times the size you think they are. I certainly don't want to be near 24, maybe 12. Yeah, 12 and then a 2. Yeah, I guess I found it. 4 and 2. Yeah, 4 times 3 is 12. I want it to be negative. Positive. Not too bad. I got myself a nice little answer now. -2/3 and +4. And putting this in graphing form wouldn't be the easiest, so I'll just check those numbers. Let's put 4 in. And if it works, we'll assume that does too. So that's 48. If I put a 4 in, minus 40, minus 8, 48 minus 48 sure gets me 0. So I'm moving on. Nothing to be said here. I mean, I can give you a little graphical practice. So 3, that's to the first power. So it's a nice linear cut. Minus 9/2 is a nice cubic cut. 5x to the 4th that's minus 4.5. So that's to an even exponent. So it's not going to change signs. So this thing looks like positive. So boom, boom, boom. But I was only looking for the zeros. So minus 9/2, 0, and 3. Any one of those numbers that you substitute in for x is going to get rid of one of your dimensions, and there will be no value to that expression. It'll be 0. And I guess that's a value. Tired brain here. You got to keep going. Got to get the reps in. Work that brain. X squared plus 19. I know that this is the same thing as x squared plus 0x plus 19, which means that I have a flat spot at 19 units high. Okay, so that's my vertex. And I got 6x. 6x is climbing. I have no idea if these intersect. They do not appear to intersect. So let's find out. X squared minus 6x plus 19 equals 0. So I have the choice here of either completing the square or the quadratic formula. I think completing the square is the easiest. X minus 3 squared minus 9 plus 19 equals 0. Yes, I do believe it's the easiest. So my X answers are positive 3 plus or minus the square root of what? 10 becomes negative 10. There's your answers. All right, you can get those. You can get those with the quadratic formula. I suppose I should do one, but I don't want to. I'm too tired. All right. So they were imaginary answers. 2x squared minus 20x plus 9. Again, you can do quadratic formula, or you can complete the square on this one because 2 goes into 20 nicely, and you can cut that in half very nicely. So I'm going to complete the square quickly. And what's completing the square? It's putting this in graphing form. So I got a 2, I got an x, I got a this. 2 goes into 20, 10. 10 cut in half, it's 5. Squared, 5 squared is 25 times 2 is 50. I don't want that 50, I want positive 9. Okay, so I just did that quickly. And now I got my roots. So minus 41 becomes positive 41 divided by 2. Taking the square root plus minus. Because I've isolated x here, I can do it, and then 5. So there's your answers to that one. All right. Yeah, I'm just doing these quickly now because I'm tired. I'm also hungry. Think I might want to go to lunch. Do I have time? No. That's all right. I'll just finish these up. All right, so I'm just going to write this answer. Most of you know how to do that, or about half of you anyway. And then I'll show you how you would know. So we're measuring from 5. So my x's are roots. So these are going to be imaginary. Did I really want imaginary? Is that what I started with over there? Yeah, I did. Okay, I got imaginary roots. So my roots are going to be the same thing as if I intersected a height of 14, except we're imagining them coming down in the other direction from the number 5. Right? And so I got to go 7 units up. So in this case, I got to go 7 units down. So it's imagining that. And A is 3. So how can you do that quickly? Well, you put it in graphing. 3x minus 5 squared plus 7 equals 0. Okay, so what do we got? We got a minus 7. We got to divide by 3. We got to take the square root plus minus. And as soon as you do that, the minus sign goes outside, imaginary. And then you got to measure from 5. That's where it comes from. All right. I got to get some space here. Final frontier. These are the wages. No, that's another open space. X plus 3y is a linear function. 11 x-intercept, y-intercept 11/3, so 1/3 of that distance. That function's going that way. This one, 3/5, 5/3 is a little bit more than 1, so maybe that's here. -1. All right, so if I'm not mistaken, we have 2 positive x and y's, and there x looks like it's a little bigger than y. But let's find out. I don't honestly know. And I could have made a mistake at this stage because I'm getting a little tired here. So I'm going to triple this one, but I'm going to multiply by -3 so I can add. Minus 3x, minus 9y, minus 33. I hate these problems. There's so many little things you have to do. It's so tedious. Positive 3x, minus 5y equals 5. Let's add those up quickly. So minus 14y equals 28. Oh, goody, minus 28. So it looks like y is 2. That's believable. We said it would be positive and small. All right, and of course, if it's 2, then you can plug it right in. And you got 6 plus what is 11, 5. So 5 comma 2, but let's find 5 comma 2 by doing the same process again, but now instead of solving for the y column, let's solve for the x column. So I guess I got to multiply this one by 5 and this one by 3. So I'll multiply this one by 5, 5x plus 15y equals 55. This one by 3, 9x minus 15y equals 15. Okay, I think I did that right. We did get a cancellation. Oh, I canceled the wrong side. We get a cancellation here. This is 14x and 55 and 15, 65, 70, and 14 goes into 75 times. Boom. All right, last problem. Look at it graphically first. All right, so 3x minus 5, square root of 0 occurs at 5/3. I know square roots, this is climbing quickly, but then very slowly. X minus 1, 5/3 is bigger than 1, so the x-intercept is 1, and it's going up at 1 to 1. So the question is, I think we're probably going to get 2 intersections, but it might miss. I'm betting on 2 intersections. Answers one of them just a little bit bigger than 5/3, or it might even be 5. No, it can't be 5/3. All right, let's find it. Okay, but I think we got 2 numbers that are a little bit near 2 and something else, maybe. But let's find out. So I'm going to square both sides, 3x minus 5. Many of you will say x squared plus 1 over here, and that's absolutely wrong. X minus 1 times x minus 1 has a middle term. Okay, and squaring a binomial, let's do this time. Square, square. We've practiced this all semester. You square the first, you double that product, which we can see up there. And so that's the correct binomial squaring process. And it's your last chance to make that part of your foundation. All right, so we set it to 0. I don't like working with negative x squared, so we'll leave x squared on this side. I think I might need a little bit more room. Take 3x, so that's minus 5x. Minus 5 becomes positive 5, so that becomes 6. Oh, this looks very friendly. X, no, it's not friendly, is it? God, I don't want to do that to you. I want these to be friendly answers for you. Did I make a mistake somewhere? Minus 2x plus 1, 3x minus 5. No, that's positive 6. Oh, I'm good. I'm just tired. Sorry. X minus 2, x minus 3, extremely tired here. So yeah, so one of them was 2 and one of them was 3. But we really should check this in the original. Because when you square, you bring in extra answers sometimes, and it's still possible. Although I don't think it's like, so let's check it out. 3 times 2, 6 minus 5 is 1. The square root of 1 is 1. And 2 minus 1 is 1. So the number 2 works. Now we try 3. 9 minus 5 is 4. The square root of 4 is 2. And what did I say? I was plugging in 3. 3 minus 1 is 2. Yes, they both work. All right, so there's your practice for tonight. Hopefully you're starting to see these problems repetitively. I know half of the class has been seeing them repetitively for the entire semester. The other half has not worked quite as hard. So here's your last chance to get your 4 days of repetition in a row. But you might want to play the video more than once. Okay, let's close this out. Get ready for class. There we go.